In this video, we will study about hypervisors and containers. We have already seen that hypervisor is a software which helps us in creating virtual machines, right? So, using hypervisors, we can select whatever RAM you need, how much resources you need, and you can create a virtual machine. Okay, so let's understand in technical terms. Hypervisor is a software process that creates and runs virtual machines and alerts the host server's compute, storage and networking resources as requested by the virtual machine. Okay, so it's a software application, it's a software process that helps us in creating and running the virtual machines. Virtual machines are also known as virtual machine monitors. Virtual machine monitors, okay, VMM, right? So this VMM help ensure that each virtual machine operates independently, preventing conflicts and optimizing performances across the multiple workloads. Okay, so hypervisor plays not only helps in creating and running virtual machine, it also takes care of the maintenance of those virtual machines, right? So hypervisor aggregates the resources of virtualized physical servers such as memory, network bandwidth and CPU cycles, and then allocating these resources to the virtual environments called virtual machines. So hypervisor's job is to aggregate the available resources in the physical servers, right, and then allot to the one who is requesting it. Okay, so this is about hypervisor. Now, what are the benefits of using hypervisor? See, if you are using hypervisor, you are not wasting much time in setting up a new environment or a new system. Instead, within a single system, you are able to do that. So only we are talking about speed, agility and scalability, right? Organizations don't have to wait or don't have to provision a new environment every time when a customer is asking. If a developer is asking a test environment, I can quickly provide it to him. So there is speed, agility and scalability because I am able to scale as many virtual machines as possible. Next one is more efficient utilization of servers. See, when hypervisors are there, the data center's resources or a physical server's resources are underutilized. With the help of hypervisor, I am able to give that resource, share that resource to other people, making sure that the resources are utilized to the full. That is also possible with the help of hypervisor. And the third one is the increased security. Right? Even though a physical host server might be running dozens of virtual machines, all those VMs are isolated. When they are isolated, the fellow who is using my server, who is creating virtual machine on my server, need not worry about security, right? And the next important one is the portability and workload balancing. Right? So once a particular virtual machine is having some problem, we can easily migrate it from one host to the other host. That is what portability, right? So decoupling the virtual machines OS and applications from one physical host, and we can easily migrate it to the another one. And next comes the cost saving. Okay, so why are we saving cost? Because the people need not spend more on the creating physical servers. They need not spend more on purchasing more physical servers, right? So virtualization enables organizations to save on capex. Capex means capital expenditure, because they can use a multitude of they can create many virtual machines on a single physical server and have less need for hardware. Instead of always going and purchasing new hardware for new request, you are saving a lot of money. You are effectively utilizing the available resources. And the final one is the faster data recovery, right? If some corruption happens in a virtual machine, you can create a snapshot of that. And it's like snapshot means in database we always do commit. Once you do some task, you will commit. Why? If something goes wrong, till that extent data will be stored, right? You have done a lot of transaction, power has gone. So what all steps you have done will be gone until the last commit phase. So it's same as that. Your virtual machines data, current state, memory state, everything can be captured as a snapshot. Okay, so if the data in a virtual machine is corrupted or infected by the malware, some hypervisors enable the organizations to restore that data from a snapshot. So rather than having full backup, you can have the snapshot. So let's say 70% application was done or processing was done, then the power failure happened. If you have taken a snapshot of that at the moment, you need not start it from the beginning. You can do it from that 70% only. That's what the benefit here, faster data recovery. So these are few benefits of hypervisor. There are two different types of hypervisor, right? Type 1 or the bare metal, we call it as the bare metal, right? And then comes the type 2, that is the hosted hypervisors. What is bare metal? What is this? Let's see this diagram and understand. See here in the first diagram, in the bare metal, the hypervisor software is installed directly in the hardware of the physical server. It has nothing to do with the operating system. Whereas in the second one, in the hosted one, the hypervisor is installed on top of the operating system, not in the hardware, but using the operating system, right? So why it's called bare metal? Because your metal means that infrastructure, and the actual infrastructure you are doing that installation. Whereas here it is called hosted virtualization, because you are doing it with the help of OS. So what we see, that VMware, VirtualBox, what we see regularly are type 2 only. We are not doing anything in the hardware part, we are doing everything in the operating system. So you have a laptop, in that there is an OS already installed, on that you are installing a hypervisor. That is type 2, right? So let's understand. So type 1 hypervisors are installed directly on the physical server, that is the host's hardware, which is why they are called as bare metal hypervisors. They don't rely on the host operating system, right? Direct access to the resources of the physical servers make type 1 highly efficient. You are directly accessing the resources, not through OS direct contact. Okay, type 2 they are different, because they run as applications on a physical server's pre-existing OS. It is like installing some software in your laptop which already has an OS. Because they run on the host OS, they sit between the physical server and the hypervisor. That's why they are known as hosted hypervisors. Okay, it is essentially an application within the host OS, right? So this type is generally used for desktop virtualization, development and testing environments, where a user needs to run multiple OS on their personal computer. So when you want to run multiple operating systems, then you go for this hosted virtualization. Whereas if you want to share your resources, you go for bare metal, right? So but performance is slower than type 1, because you are depending on the host operating system. Okay, so two different types of hypervisors, bare metal and hosted, right? Bare metal is installed directly on the physical hardware, whereas hosted is installed in the using the operating system of the host machine. So these are different types of hypervisors. Difference between both bare metal and type 2. See, the bare metal is installed directly on the physical server. This runs as an application on top of host OS. Advantages: bare metal is highly efficient, strong security and all those benefits. In type 2, it is easy to install, suitable for individual users running multiple OS. Drawback here, it requires a dedicated hardware in bare metal on type 1. But here type 2, it is higher latency, because it is working as a software application, but it is more vulnerable to security risk. Okay, some examples of this are VMware, ESXi, right? Citrix hypervisor, all these are bare metal one. But the one which we regularly use, VirtualBox, VMware, right? All these are type 2, that is hosted hypervisors. So this is a little difference between type 1 and type 2 hypervisors. So this is all about hypervisors. Now let's understand what is a container. When we have studied microservices, we have talked about containers. Container is a standard unit of a software that packages an application, its all dependencies. Along with the code, what all stuff is required to run that application, everything is dumped into that container, right? So see, it's a standard unit of software that packages an application and all its dependencies, code, runtime, system tools, libraries, everything. Okay, container is a lightweight package that contains an application plus everything that needs to run. Okay, see, so it allows applications to run independently of an operating system. Irrespective of the OS, that application will work. You write microservice in one language, right? You might have designed it in some operating system, but it can run in any operating system. That is possible here. Okay, then containers are extremely portable. You can move from one machine to the other machine easily without any challenge. Okay, they can run in any operating system. All that they need is a container engine to run. They need a container engine to run. Okay, so the common use for containers is enabling microservices and web applications. Mostly we use containers for microservices because we have lot of microservices says it can be written in any language. I want to shift them from one place to other place easily, right? So there are a lot of benefits of using the containers. But a very common question what appears is, what is the difference between a hypervisor and a container? So I think this diagram should help you understand what is the difference between a hypervisor and a container. See, hypervisor is for distributing the hardware, underlying physical resources I want to effectively utilize. So I am going for hypervisor. Whereas container, it is for running the applications anywhere, independent of the operating system. Right. So containers are the best fit when speed, portability and lightweight efficiency are the top priorities. Okay, they excel very well in cloud native environments, in CI/CD pipelines and microservice architectures, where fast boot times and high density are most critical. Whereas hypervisors are the right choice when you need to run multiple operating system. Okay, when you want to run multiple operating system, you go for hypervisors. Both are different, they do different tasks, but the architectural diagram looks same. Underlying there is a physical machine, on top there is a host operating system. Here there is an hypervisor, here we have a container engine, right? So this is for distributing multiple operating systems, but in container we don't talk about operating system, it's a single operating system there, but we pack everything inside a container which is required for running an application, right? So this is a very popularly asked Viva interview question. What is the difference between a hypervisor and a container? Hypervisor is used for running multiple operating system, whereas containers are used for easy portability, to run a application in any operating system easily. We use the containers. Okay, so this is about hypervisors and containers. Thank you.